Have you ever stopped to think about what would happen if a truck used only one wheel per side on the rear axle, just like a car? At first glance, it seems like a trivial question. The truck weighs more. And for a second, that explanation seems sufficient. But if the answer were that simple, the solution would be two. A larger wheel or several different ones, any imaginable alternative. And yet, that is not the case. Instead, almost all the trucks in the world use exactly the same configuration, two wheels together. And the most striking thing is that most people who see a truck on the road do not even notice that detail. It is there in plain sight, but it goes completely unnoticed. Only when one stops to think about it does another dimension appear. It is no longer a matter of habit or an arbitrary decision. Behind that choice there is physics, safety, load distribution and efficiency. There is a level of logic that is not appreciated at first glance. Trucks do not use dual wheels by tradition. They use them because literally they could not operate safely without them. And that is where the real intrigue appears. A car of barely 1 ton can perfectly support itself with a single wheel per side. But a 40-ton truck not only needs to brake, accelerate and remain stable, it must do so for thousands of kilometers on hot asphalt, wet roads and uneven paths, under conditions that put every last component to the test. This is no longer just a matter of weight. It is a matter of mechanical survival. The question then is not why trucks use dual wheels on the rear axle, but something much deeper. What does a single tire really carry when a truck is in motion? To answer it, one has to widen the perspective. A truck weighs far more than most people imagine. When seeing an articulated truck moving with apparent smoothness along the road, it is hard to grasp that this machine concentrates dozens of tons in motion on just a few points of support. That colossal mass is not distributed evenly. It is concentrated, and it exerts enormous loads on very specific points of the structure, mainly on the rear axles. A tractor unit with semi-trailer in Europe usually operates with a total gross weight that ranges between 36 and 44 tons, depending on the configuration and the regulations of each country. In the case of the United States, the typical federal limit is 80,000 pounds, which is approximately equivalent to 36 tons, although some states allow even more. And this is only the legal weight because the structural capacity is often higher, but the law sets limits to protect roads, bridges and traffic safety. Now, breaking down this figure helps to understand the reason for dual wheels. An average car weighs around 1,400 to 1,600 kilograms. A rear axle of a truck can support by itself up to 11,000 or 13,000 kilograms. That is the equivalent of 7 or 8 compact cars loaded onto a single point. That disproportion is not accidental. The trailer places a large part of its weight on the fifth wheel and transfers the load directly to the drive axles. That weight is not distributed by magic along the chassis. Most of it falls on the rear axles, since that is where the main anchoring point of the semi-trailer is located, and in addition they are responsible for transmitting the engine's force to the pavement. This creates a critical load region. The rear tires support not only the static weight of the load, but also the dynamic one, the one that appears when the truck accelerates, brakes, climbs slopes, or goes over potholes and undulations. Each wheel is, in essence, a point of support that must absorb tons and tons of force in fractions of a second. And it is at that point where the key fact appears. The maximum capacity of a truck tire is around 4 to 5.5 tons, depending on the model, the pressure, and the speed to which it is subjected. That is, even the best tire on the market has a non-negotiable physical limit. If a single wheel were placed per side on a rear axle that must support 11 tons, that single wheel would be overloaded even at rest. In motion, with heat, lateral deformation and dynamic loads, failure would be inevitable. The rubber would overheat, the internal carcass would collapse, and the tire would explode in a matter of minutes. Because here it is necessary to remember something essential. Weight generates heat, and heat is the #1 enemy of the tire. When the wheel supports more load than it should, it flattens more against the pavement, deforms, internal friction increases, and the temperature rises. And when that temperature rises, the structure weakens and the risk of a blowout skyrockets. A single wheel per side could not handle this type of demand. For that reason, only duplicating the number of tires makes it possible to distribute the load, reduce pressure on the pavement, and maintain the structural integrity of the assembly. However, although weight explains a fundamental part of the problem, it is not the only reason why we see dual wheels on trucks. Even if one were to think of a somewhat lighter truck, single wheels would continue to face problems that do not depend solely on the vehicle's weight, but on how that load is transmitted and distributed at the contact with the asphalt. So, if weight is only the beginning, what exactly happens between the wheel and the pavement that makes it impossible to use a single rim per side on a truck? Let us imagine for a moment that seemingly logical solution. If a truck weighs so much and demands so much from the pavement, why not place a single gigantic wheel on each side and be done with it? Intuition points in that direction, but the idea collapses as soon as we look at what really happens at the point of contact between rubber and asphalt, because the problem is not just the size of the wheel, but how pressure is distributed on the ground and how the friction that keeps the truck stable and controllable is generated. To begin with, the contact area between the wheel and the road is much smaller than most people imagine. Even a huge wheel does not rest on a gigantic surface, but on a relatively small portion that supports all the weight at that moment. If that area were too small, the pressure would be so high that wear would accelerate, internal heat would increase uncontrollably, and every pothole would transmit a brutal odor to the axle. But if it were too large, problems would also appear, since rolling resistance would increase, more effort would be required to set the truck in motion, and fuel consumption would skyrocket. The key then lies in a delicate balance between contact surface, pressure, and friction. Now then, what would happen with a truly gigantic wheel? The answer is simple. It would be a real disaster. And not by exaggeration, but because a huge wheel would deform much more under load, generating excessive heat and compromising the internal structure of the tire. That additional deformation would also increase rolling resistance, making every kilometer require more energy and raising fuel consumption to unsustainable levels in commercial transport. And, as if that were not enough, by increasing the height of the axle, that enormous wheel would shift the vehicle's center of gravity and make it much more unstable in curves, maneuvers, and braking. In addition, a single giant wheel would concentrate internal stresses that over time would cause deformations and premature failures. That would require rims and suspension systems completely different from those used today. It would be a technically possible solution, but economically unviable and operationally impractical. But even if we already understand why a giant wheel is not a real option, there is still an open question that is even more important to understand the design of a modern truck. What role do dual wheels play exactly in traction and braking, and why does that configuration turn out to be so superior to any alternative? The answer begins here and becomes truly interesting when we look at something that few usually take into account: lateral stability. Because a truck does not only carry dozens of tons downward, as it moves, it must also resist forces that push it sideways every time it turns, changes lanes, or faces a gust of crosswind. And when those forces are not well controlled, even if they are not visible, they can endanger a large vehicle. A truck that takes a curve at moderate speed experiences an inevitable phenomenon. The total weight tends to keep going straight while the chassis tries to change direction, and in that attempt, a strong transfer of load toward the outer side of the turn occurs. That pressure is not distributed evenly over the wheel. It shifts to one side, it compresses it and deforms it. And in that deformation, it reduces the effective contact surface with the asphalt. If there were only a single wheel, that tire would absorb all the lateral load. It would lose stability. The risk of extreme deformation would increase. And in the worst case, it would compromise grip right when it is most needed. And when we are talking about vehicles that can weigh dozens of tons, a loss of grip in a curve can turn into a serious incident in a matter of seconds. But that is not what happens with dual wheels. The behavior changes completely when the load, instead of concentrating on a single tire and absorbing all the lateral distortion, is distributed between two contact points and modifies the way the axle responds to the turning force. In that configuration, the inner wheel acts as an additional support that prevents the outer wheel from collapsing or leaning too much. In this way, the truck stops relying on a narrow and vulnerable point and begins to rely on a wider, stronger, and more stable base. It is as if the vehicle had broader shoulders to support itself during demanding maneuvers. And that same distribution of effort reduces heat buildup, prevents excessive friction at a single point, and significantly improves the ability to maintain the trajectory in extreme situations. To understand it better, let us imagine a specific scenario. A tanker truck takes the access ramp to a highway with the tank partially filled, which already implies internal movement of the liquid. Halfway through the turn, a crosswind pushes the trailer while the driver corrects the trajectory. In those seconds, stability depends entirely on the lateral grip of the rear wheels. If there were only one per side, that wheel would absorb most of the impact, deforming and increasing the risk of loss of control. With dual wheels, that force is redistributed. The inner wheel supports the outer one, preventing the assembly from sinking or shifting abruptly. What feels to the driver like a safe and controlled maneuver is in reality the result of finely calibrated engineering. This same lateral stability also influences tight turns in depots, low-speed curves in urban areas, maneuvers inside ports, and any situation where the weight shifts to one side. Dual wheels not only increase grip, they also allow the truck to maintain the shape of the footprint on the ground, which ensures a wide, stable, and resistant contact against forces that a single wheel simply could not withstand without compromising the structure. Now that we understand that dual wheels are not a whim or a tradition, but an essential tool to maintain the lateral stability of a truck that carries extreme loads, an inevitable question arises. If these wheels fulfill such critical functions, then do they really all work all the time, or is their operation more complex than it seems? When we understand that each rear wheel of a truck works under thousands of kilos of load and that its function goes beyond simply rolling, it becomes inevitable to ask what happens when one of them stops fulfilling its task. A flat tire in a car can be a scare, but in a large vehicle it is a completely different scenario, because if a single rear wheel were to fail without additional support, the entire structure of the truck would feel an immediate imbalance that could turn into a loss of control. That leads us to the true reason why the dual system exists: safety based on redundancy. Without that backup, in a truck with single wheels, a rear blowout would mean that in a matter of seconds that part of the axle would sink and the trailer would begin to tilt, abruptly altering the trajectory. In that movement, the weight would shift to one side, the truck would tend to veer toward the shoulder or into another lane, and the driver could lose control even if he reacts quickly. At highway speeds, with dozens of tons pushing forward, this type of failure leaves no margin for maneuver. A single tire was not designed to support that much load without backup, and that fragility makes it impossible to rely on single wheels in this area of the truck. Faced with that scenario, the pair of wheels completely changes the situation. If one wheel loses air, its twin absorbs part of the load and compensates for the initial unevenness, preventing the truck from tilting suddenly or the trajectory from becoming immediately unstable. It is not that driving continues in a perfect manner because the driver feels abnormal vibrations, hears a different sound, or notices a slight tendency of the trailer to move erratically. But the truck remains controllable, the steering continues to be precise, and there is enough time to reduce speed and stop in a safe place. This margin for maneuver is exactly what saves lives. To visualize it better, let us imagine two real situations. On a highway, a truck runs over a metal object that punctures one of the rear wheels, and with a single wheel configuration, the vehicle tilts and can invade another lane before the driver even manages to react. With dual wheels, on the other hand, that same situation unfolds in a different way. The truck maintains its line and the driver can brake progressively until exiting the roadway. In the same logic, something similar occurs on a moderate descent, where the weight pushes strongly forward. A blowout on a single wheel would be very close to turning into a rollover, but with dual wheels, the second wheel becomes a temporary support that prevents a total loss of stability. But this system is not infallible if it is neglected, because when two wheels work together, both need correct pressures, uniform wear, and periodic inspection. If one wheel is overinflated and the other too low, most of the weight always falls on the same one, and if that is the one that fails, the twin will not have sufficient structural integrity to support the load. It is not a matter of complex maintenance, but of understanding that the safety of the system depends on both wheels working under equivalent conditions. Hence, dual wheels at the rear are not a luxury or an excess, but a layer of safety designed to prevent a simple puncture from turning into a tragedy. They are a constant backup that allows the truck to be controlled even when something goes wrong, and they represent a level of protection that light vehicles simply do not need. But if dual wheels are so crucial when one fails, what happens when both work together at full capacity? How do they influence traction, braking, and stability, even when everything works perfectly? Even if tires never failed and safety did not depend on redundancy, dual wheels would still be there for a reason that goes beyond engineering and that influences more than any manufacturer's decision. That reason is axle weight laws, a set of regulations that not only determine how much a truck can carry, but also how it must be designed so as not to destroy the infrastructure on which it travels. This means that many decisions that seem technical are actually dictated by international standards that set strict load limits. And those limits shape every centimetre of the truck. To understand it, one must start from a simple idea. Roads, bridges, and highways are not indestructible structures. When millions of heavy vehicles circulate constantly, the pressure that each wheel exerts on the pavement becomes a critical factor. No matter how strong the concrete is, if a single point supports too much load, the surface ends up deteriorating. For this reason, axle weight limits exist, which establish how many tons an axle can legally support before it begins to damage the infrastructure. In Europe, these limits usually range between 10 and 12 tons per axle, while in the United States there are similar values, although with different combinations depending on the total length of the vehicle and the number of axles. Now then, if an axle had only one wheel on each side, the entire load would fall solely on 2 contact points. That design would not only be unsafe but illegal because the pressure per square centimetre would be too high for any authorised pavement. The single wheel would concentrate so much force on such a small surface that it would break the limit before the truck moved a single metre. By contrast, when dual wheels are used, the contact surface is doubled and the weight is distributed more evenly, reducing the pressure to the level dictated by the regulations. It is not a whim or a decision inherited from the industry, but a legal necessity in order to operate within the permitted margins. Ultimately, dual wheels do not exist only to distribute effort or improve stability. They are the most efficient and economically viable way to comply with the laws without completely modifying the truck's architecture. But even the best design has a limit. Because one thing is how the law and engineering define the structure of a vehicle, and another very different thing is how that system works day after day on the road. And that is where a key question appears. If dual wheels depend on such a precise balance, who is responsible for ensuring that this balance is maintained? And what happens when that control fails? If the laws determine how a truck must be built and engineering defines the way each wheel supports the weight, the final link in this chain is the person behind the wheel, because no configuration, no matter how robust, works properly without a strict routine of control and maintenance. Dual wheels are not a passive system. They are not an element that is simply there. They depend on the constant vigilance of the driver, on their experience, and on their ability to detect minimal signals before they turn into real problems. That daily responsibility is as important as any law or structural design. A driver who works with dual wheels knows that the first thing to check before starting a trip is the pressure of each tire. Although they work in pairs, both must have similar pressures because if one is more inflated than the other, it will absorb a greater part of the load and wear out quickly, reducing the useful life of the assembly. If, on the contrary, one wheel is too low, the twin will support almost all the weight on every turn. That imbalance can cause excessive heating and eventually a blowout. Unlike a car, where it is enough to check 4 wheels, here each tire has a partner with which it must remain in balance, and that control is essential to travel safely. In addition to pressure, the driver must check the space between the dual wheels to make sure there are no trapped objects. It is more common than it seems for stones, pieces of wood or metal debris to become lodged between them, generating constant friction. That friction can wear the rubber unevenly. It can cut the tread or even overheat the surface until it degrades. For that reason, many drivers perform a complete visual inspection before each workday. They crouch down, look between the wheels, and make sure there is nothing unusual. But not everything is visible at first glance because temperature is also a critical indicator. On prolonged descents, when the brakes work harder than usual, heat can be transmitted to the wheels and leave an uneven thermal signature. An experienced driver knows that if one wheel is significantly hotter than its twin, something is not working properly. It could be incorrect pressure, different wear, or even an object that is generating resistance. Those small signals are what differentiate a novice driver from one who knows their vehicle in detail. Sensors and modern systems help, but even today human observation remains irreplaceable. And those signals do not appear only when the truck is stopped. They also manifest themselves while driving through small vibrations. One of them, slight, repetitive, and localized in the rear, may indicate that the inner wheel lost air or that wear is not uniform. When that happens, the driver knows that they must look for a safe area to stop, inspect the wheel, and decide whether they can continue or need assistance. These types of decisions are not made by reading a manual. They are made by having lived through hundreds of similar situations, learning to recognize how the truck's behavior changes when something is not right. And that experience is not activated only when the vehicle is already in motion. It is built much earlier, in the routine before the trip. The initial inspection is one of the most important tasks, striking the tires with a bar to listen for the proper resonance, checking the valve caps, inspecting the lug nuts, and observing wear. They are simple gestures, repeated every day, that can prevent catastrophic failures on the road. Engineering offers tools, but it is the driver's discipline that keeps them alive. A well-inspected tire lasts longer, works better, and keeps the entire vehicle stable. And when we are talking about an assembly of several tons, that stability is essential. That is why, although dual wheels exist for technical, legal, and structural reasons, their final effectiveness depends on those who inspect them daily and on those who know how to interpret them while in motion. They are not just part of the truck, they are part of the profession. They make it possible for all the machinery to function as it was designed, while the driver provides judgment that no regulation or technology can replace. Understanding how the driver's routine sustains the daily operation of dual wheels and how each inspection prevents failures that could turn into real emergencies, it becomes evident that this system is not just a technical decision or a simple design resource. It is the meeting point between engineering, laws, safety, and human experience, a mechanism that supports tons of load while facing thousands of kilometers of road. And understanding it allows one to look at a truck in a completely different way. What began as a simple question, why trucks use dual wheels on the rear, led us to discover that the answer involves factors that intertwine with one another. From the real weight that each axle supports to the physical impossibility of handling that load with giant wheels, including the need to distribute the effort over a larger area to protect both the vehicle and the pavement. Added to that are axle weight laws, which force the use of configurations that not only work well, but also respect the infrastructure. And finally, the role of the driver appears, whose daily routine ensures that this entire system remains stable, balanced, and safe. The central idea becomes clear. Trucks use dual wheels not for aesthetics or tradition, but because it is the most efficient and safest way to support large loads without compromising the stability of the assembly. Dual wheels distribute the weight, reduce pressure on the asphalt, keep the truck straight in critical situations, and offer vital redundancy when a puncture occurs. They are ultimately a solution that combines engineering, legislation, and practical sense so that these colossal machines can operate reliably day after day. And perhaps the most fascinating thing is that such an everyday detail, two wheels together on the same axle, concentrates a complexity that goes unnoticed by most people. Because behind every truck that moves along the highway, there are structural decisions, millimetric calculations, and maintenance routines that sustain the movement of an entire country. Seeing these wheels with different eyes is understanding that every element on a truck exists for a precise reason. If you want to continue discovering how these machines really work and what secrets the systems we see every day without noticing actually hide, subscribe to the channel and join us in the next videos. There is much more to explore, and each topic opens the door to a new chapter in the world of heavy transport. Because behind every wheel, every axle, and every road, there is always a story of engineering worth telling.